I am Anil Kumar. Welcome to my YouTube channel. In this video, I'm going to discuss a very interesting question which is based on random variables. Before we begin, let me thank all the participants of our free math solutions WhatsApp group. Now, this free math solutions WhatsApp group provides solutions to many of the participants free of cost. Let me appreciate one of the most active member in this group, Mr. Narath. Single-handedly, he had been solving thousands of questions every day. Now, the question which we have picked up here is actually very interesting, difficult to understand, and Mr. Narath provided the solution for this particular question. I am here to discuss with you at length how should we solve such questions. Thanks to the group members for providing such a beautiful question and the solution. You're also welcome to join the group. I'll provide a link for the same at the end of the video in my comments. Now, let's look into the question itself. I just named it as even numbers. The question here is, the random variable x is the number of even numbers obtained when two ordinary fair die are thrown. The random variable y is the number of even numbers obtained when two fair pentagonal spinners, each numbered 1, 2, 3, 4, and 5, are spun simultaneously. So in the question, we have defined two independent events. One, variable x for a normal dice, right? So that means there are six possibilities there, correct? So one, we're talking about a normal dice. Two of them are thrown simultaneously, right? So that is the question. We need to figure out when you throw two of them simultaneously, how many even numbers are obtained. So that is defined by the random variable x. The other random variable y is defined by spinning a pentagonal spinner with numbers 1 to 5. We need to figure out how many even numbers do you get when two of these spinners are spun. Correct? Now, based on this, there are two questions. One, find E of x, E of y, E of x plus y, variance of x, variance of y, variance of x plus y using probability distribution. And part B is to verify that E of x plus y is equals to E of x plus E of y, and variance of x plus y is equal to variance of x plus variance of y. So you need to work on expectations and variance for the two events and also the event which we are saying x plus y. Correct? So that is the question. You can always pause the video, answer this question, and then look into my suggestions. Again, I'm providing you with a solution which was provided by Mr. Narad. Here is how we'll understand its solution. One by one, we'll go step by step. So let's look into the question once again. We are saying the random variable x, so we have to define this random variable x, which is the number of even numbers obtained when two ordinary dice are thrown. Correct? So when you throw two ordinary dice, you may get one even number, you may get two even numbers, or you may not get any even number. Correct? So to understand this, what I've done here is shown you that two dice possibility is to get numbers 1 to 6 from each. And when you throw them simultaneously, then what can you get? If you get 1 and 1, that means we do not get any even number. So 0 indicates no even number, right? So when I say 0, that means no even number. And 1, of course, will mean one even number. and 2 will mean two even numbers. Perfect. For example, if you get 1 and 3, if you get 1 and 3, in that case, result is that we do not have any even number. But if you get 2 and 5, in that case, we have one even number. But if you get 4 and 6, right, in that case, we have two even numbers. You get the point. So we're just counting how many even numbers you get when you throw the two dice. So from this matrix, you can easily see what is the number of even numbers you get. So you may basically get either zero even numbers, one even number, or two even numbers. So this random variable x can take one of the three values 0, 1, and 2. Now let's look into the pentagon. So when we have two spinners, we have options 1 to 5 for both. Now, if both get 1, then it's not an even number. But if you get one of them as 2, you get one even number. So from this matrix also we see that maximum number of even numbers you can get is of course 2, where there are two pentagonal spinners. And this total numbers possible are 1, 2, or 0, right? None of them is even when you spin. So y also has the values 0, 1, or 2. So we have defined our random variables x and y clearly. Perfect. Now, let's look into the expectations. Perfect. So I hope you have understood this part. And from here, you can actually see the expectations also. So now let's calculate the expectations for each. So what we just understood is if we have two ordinary dice and the random variable x denotes the number of even numbers, right? So we are looking for the number of even numbers. In that case, zero number of even numbers means, let's count how many zeros do we get. That means both the dice are giving us odd numbers, correct? And that results into no even number at all. So you can see from here that there are 9 possibilities out of 36, and therefore the probability of getting zero number of even numbers while throwing two dice is 9 over 36, which is 0.25. Now one number of even number is where? So you can look for the ones now, right? So one number of even numbers very clearly. Most of them as being shown here in blue. So we get one number of even numbers. Correct? So if you count all of them clearly, you know how many even numbers are there. Right? So this is 18. 18 of them will give you one even number. When two dice are thrown simultaneously, 18 by 36 is 50%. The remaining, both even numbers, you get when 9 possibilities are there, right? Both give you even numbers. 9 out of 36 gives you 25%. So that is how we find the probability for each event. Now let's look into the second case, which is when we spin two spinners which are pentagonal. So we know the number of even numbers could be 0, 1, or 2. Making the same table here, working out the values, we get for zero number of even numbers, total is 25 in this case, 9 out of 25, that gives you 0.36. For y equals to 1, probability for one number of even number when you spin two pentagonal spinners is 12 over 36, which is 0.48, and the probability for y equals to 2 is 4 over 36, 0.16, right? Well, of course, when you add up all the three, you will get 1. Perfect. So I hope till now it is very clear how do we define our events, what are the possible numbers they can get, and what is their probability. Now it's time to find the expectation and variance. So let's calculate this. So clearly, for the two ordinary dice thrown together, we found that x could have values 0, 1, and 2. And the probability for each was calculated as 25%, 50%, and 25% for x equals to 0, x equals to 1, and x equals to 2 respectively. Now you need to find the expectations. What is expectations? Well, apply the simple formula. We need to multiply the value xi with the probability of xi to get the expectation, right? So expectation is the value and its probability when multiplied together and add them up, right? So you need to add this up, correct? So when you add this up, you get the expectation, and clearly it is 0 times 0.25 plus 1 times 1.0.5 plus 2 times 0.25. That gives you 1. Now to find the variance, we will do, now we know that the expectation is 1. So the variance will be 0 minus 1 whole square times the probability distribution, correct? So you get the sum of these will give you the variance, add them up to get the value. It comes to 0.5, and that is how you find the variance. Is that clear to you? So we have calculated both expectation and variance for the two ordinary dies. Well, you know now how to calculate it. You can now pause the video and do the same calculation for the pentagonal prism, a spinner, right? So let's do it. I hope you must have got the same answer for the two fair pentagonal spinners where the random variable y can take the values 0, 1, and 2. We did find that the probability distribution for y equals to 0, we get 0.36. For y equals to 1, 0.48. For y equals to 2, 0.16. Expectation is to multiply these numbers together and add them up. And when you add them up, 0 times 0.36 plus 1 times 0.48 plus 2 times 0.16, we get 0.8. And that becomes the expectation for our second event, y. To find the variance, 0 minus 1, 0.8. I should have written 0.8, sorry. So this value should have been 0.8. So let me change these values. Correct. So 0 minus 0.8 whole square times 0.36, 1 minus 0.8 whole square times 0.48, 2 minus 0.8 whole square times 0.16 gives you 0.48, correct? So make this correction since the expectation is 0.8, right? You should write 0 minus 0.8 and then find the variance. So we get a value 0.48. So we have calculated the expectation and the variance for the second event where the two pentagonal spinners are spun together. Now, what is the event x plus y? We need to work this out. So in x plus y, we are looking for how many even numbers do we get. Now think like this, that means that we have two things. One, we have two dies, that is one event, right? And the other event is that we have two spinners, pentagonal. Right, so let's say these are our two dies. And then we do have two spinners here, right? Now these spinners are divided, they have numbers 1 to 5. 1, 2, 3, 4, 5. Correct. So divide into 5 equal parts. Now these are together taken. This is the event which is being defined as x and that as y. So what is x plus y? And we are looking for number of even numbers, correct? Now we know clearly that if I take the event x, for example, in that case we have the possibility of 0, 1, and 2 number of events, right? So this is for x. And for y also, we have a possibility of getting 0 number of even numbers, 1 number of even number, or 2 number of even numbers. When you combine the 2, that is x plus y. So if both give you 0, 0, I mean no even numbers, net result is that you do not get any even number. So for this combined event, which is x plus y, we do have possibility that you may get no even numbers. If one of them gives you an even number, the other doesn't, then you could get one number of even numbers. And if one of them gives you two even numbers, the other one doesn't, then we get two number of even numbers. However, if both give even numbers, in that case we could get four even numbers. And if one even number comes in one of these and two even numbers on the other one, right? In that case, we get three even numbers. So clearly in this case, the variable x plus y could take the values 0, 1, 2, 3, or 4. Perfect. Now, let us figure out the probability distribution for this combined event. Right? So, when will this value x plus y be 0? That means there's only one case that both of them do not get an even number. So, the probability for x plus y equals to 0 will be probability when x is 0 times probability when y is 0. We have already found these probabilities. Multiplying them, that is 0.25 times 0.36, gives us the result 0.09. Clear? So that is how we'll develop this process, right? Now, when do we get one number of even numbers? That means one of them gets an even number. Either x gives you even number or y gives you even number. Adding them together gives us the net probability, right? So the probability for x plus y equals to 1 is probability when x equals to 1 and y equals to 0, or probability when x is 0 and y equals to 1. So that gives you the value 0.30. Similarly, what is the probability that we get two number of even numbers when we throw two dice together and we spin two spinners together? In that case, two number means either one of them gets 0, the other one gets 2, right? So one of them gets 0, the other one gets 2. So these are the two cases, or both of them get 1 even number each, right? So multiplying their probabilities together, since they are independent events, we get 0.37 as the probability for this event. When do we get three number of even numbers? Clearly, one of them should be two even numbers and the other one should give you one even number. So that gives you the case x equals to 1, y equals to 2, or x equals to 2 and y equals to 1. Multiplying their probabilities, we get 0.20. And how do we get x plus y equals to 4? That is possible only if both of them give you an even number, right? So that is 0.25 times 0.16 gives you 0.04. And that is how we will calculate the probabilities for both x plus y as shown here. I hope this is absolutely clear, right? Once we know the probability, we can now find the expectation and the variance. So let's move forward. So now we know that x plus y, there are four possible numbers for the number of even numbers. Either you get no even number at all, or you get one even number, two, three, or four even numbers. Now probability we just calculated for x plus y. No even number was 0.09. For 1 it was 0.30. For 2 it was 0.37. For 3 it is 0.20. And for 4 it is 0.04. To find the expectation, we are going to multiply them and add them together. And that is what has been done here to get the result 1.8, right? So the expectation for x plus y is 0 times 0.09, 1 times 30, 2 times 0.37, 3 times 0.2, 4 times 0.04, add them up. Sum of all this gives you the expectation. To find the variance, well, we know that the expectation is 1.8. So the number 0 minus 1.8 whole square times the probability 0.09. 1 minus 1.8 whole square times 0.03. 2 minus 1.8 whole square times 0.37, 3 minus 1.8 whole square times 0.2, and 4 minus 1.8 whole square times 0.04 gives you 0.98, and that becomes the variance for this particular case. Perfect. So that is how we'll actually solve part A of our question, right? Now, let us verify our result. So let's look into the part B, where we want to just verify that the expectation for x plus y, is it equal to the expectation for the sum of Ex plus Ey, and also the variance x plus y, is it equal to variance of x plus variance of y? We have all the values. We can add them up and verify. So expectation x plus expectation of y is 1 plus 0.08. We get 1.8. And here also we got that the expectation of x plus y is indeed 1.8, right? So it verifies the result. Clear? Similarly, for the variance of x plus variance of y is 0.5 plus 0.48, which is equal to 0.98. And we also get 0.98 as the result for the variance in this case. So that confirms that our solution is perfectly fine. So I hope with this you understand all the steps involved in solving such a beautiful question. Let me once again thank Mr. Narad, the Vibrant Group, Free Math Solutions WhatsApp group. You can always join this group clicking at the link which is being provided in the comments below. We want participants who can post good questions and participants who can provide good solutions. Thanks for your time and all the best.